Hello, welcome to Point on Studio. It's been for a while since last time I upload video. It's been a bit busy last couple of weeks, so I'm sorry about that. Anyhow, I'm going to continue Rhino top 50 commands for architects and engineers. Last time I was showing around basic tools, how to use surface tool. Today I'm going to continuing showing some solid operations and solid tools in Rhino. So I think yeah, it's not going to be too complicated, so I hope you enjoy the video. Then let's get started. So from last week's the example file here, I'm going to now showing some of the solid operation. So basically we looked at surface tool that we could use in Rhino, and today, actually a couple of days ago, Rhino 7 is officially came out, so published, so we can use actually Rhino 7 from today. The tool, most of the functions are same. In Rhino 7 we have now subdivision and some more advanced mesh operation. We'll talk about this couple of commands next time, but today we're gonna focus more on solid operation. So a solid object, if you look at on here left side, you can see we have box, cylinder, sphere, and sphere diameter, or ellipsoid, and we have donuts and all this solid object. But it's nothing complicated. Basically, when I click on box, Rhino always shows here the next step which to follow. So when I click here, first corner, and then another base, and then I can put the height. And solid is basically nothing complicated. It doesn't have any naked edge. So if you go to surface tool, on here in the ribbon, we have here we can analyze naked edge. So I'm gonna click on it. So we should have some extra window. I'm gonna pop it up. Mark naked edges. So if I click, as you can see, we have here naked edge is showing. As you can see, this is showing all edges, but when I click on naked edge means there's some gap between surface. So Rhino is basically showing that this, if there is a gap, naked edges, then it's not 100% enclosed solid object. So let me demonstrate quickly. We can explode. I can select, and you can type command, or I can just click on explode, and as you can see now, they are every single surface, means we have always each side we have naked edges. So I'm just going to here, from last time we have the scale 1D command, and when I scale, I can maybe make it really small gap. I'm gonna disable the snap, so it's really small gap. Sometimes you don't really recognize with your eyes, but there is gap. So if I turn off this naked edge tool, so I'm just gonna join them, and you don't know, you might think I'm gonna type what, so it shows polysurface. So you may think there is you know, it's complete enclosed solid object, but it is actually there is a naked edge. So if I type what here, it shows extrusion. Extrusion means like we because we draw box based on profile and we extrude up, so it's like extrusion. But I'm gonna explode this and then join it again. So when I type what, then we have polysurface, which we can see clearly that we have ice curves from the display mode. I'm just gonna type display setting properties, and here I'm going to hide surface ice curve. So you know, when we hide ice curve, then you can clearly see there's not much difference between extrusion and polysurface. But when I enable the ISO curve, then you can see that's actually not extrusion, but it's a polysurface. So when I go now naked edge tool, I'm gonna click once more, and to show which one we're going to show, I select and put naked edges. I selected it. So when you look on the right side, as you can see, obviously this is like clearly there is no naked edge, but here we can see there is a small gap. With our human eye, maybe it's very difficult to recognize, but this tool is very handy to find out naked edge. I'm going to click on zoom, then it's just zoom in, and it shows, as you can see, there is naked edge. So I'm just gonna explode once more, and I'm going to, you know, we can scale one. There are many different ways, but I'm just gonna scale again, enable my off snap, and I'm going to enclose it by scaling. And if I join now, then as you can see, we don't have, let me go once more, and I'm going to select, and as you can see, we don't have any more naked edge, means this is perfect solid object. So basically this here, all the cylinder and you know, sphere, torus, these are all solid element, and we can do some interesting operation with solid object. For instance, it's really basic, but we can overlap between the box. I can push it up a bit with a gumball, and for instance now, if I do Boolean, if you type Boolean, we have a couple of options here. You can see nothing complicated, or probably we can also find out from our standard tool. If you go here, Boolean, so when you look at these icons, it's very easy to understand. So first one is called Boolean Union. What it does is basically joining them together as a one solid object. So if you, as you can see, this is now is complete joined, unioned solid object. And if I type what, it shows polysurface. Let's have a look once more if there is a naked edge or not. So as you can see, there is no naked edge. It means it's complete solid. When it's complete solid, of course, it's really handy. So now I'm going to continue show a couple of different solid operations. By the way, this solid operation, you can always come from standard, and then when you hold your mouse left key for a while, click and hold it a bit, then you can take out all these solid tools. Or you can go on here, you can see the same toolbox. So I'm just gonna close it. I'm gonna show from here solid tools. And next thing what you can do is I'm going to move this one with our gumball, and this time we can do Boolean difference. So it's like same as here in this icon. We can select first object which we want to keep it, and then we can select second surface or polysurface which we want to subtract with. So when I press enter or spacebar, as you can see, this Boolean difference operation is executed. So I'm just gonna undo. I'm gonna do one more time in the other way. So Boolean difference, I'm gonna select these boxes, I mean this union box, and hit enter, and I can use now select surface or polysurface to subtract with. I'm going to hit spacebar. Then as you can see, we have this Boolean difference operation. Next we can go to Boolean intersection. So we can basically get like sort of overlapping geometry. So let me scale a bit of this sphere. So we have now elliptical solid object. And what I'll do now, I'm going to do Boolean intersection. So select first set of surface or polysurface. So I'm gonna select these boxes, and second set or surface, enter. And as you can see, this area here, if you look our I can go to ghost view. To go ghost view, you can do Control Alt and G. If you press Control and Alt and G, that's ghost view. Control Alt and S, that's shaded view. Control Alt and W is wireframe. I'm just going to show you, and there's Control Alt and X, which is X-ray view, but I'm going to go ghost view, Control Alt and G for girl. And as you can see here, you can see where the geometries overlap each other. So I'm gonna operate one more time. This time I select the sphere, this manipulated sphere, and then second one, if I select, and these overlapped area only survive and the other geometry is deleted. So let me go back and have a look. If you look, this area is not overlapped, and basically overlapped area is, you can see here in this area and also in this area. So I'm just going to use Boolean intersection. I'm gonna select box and sphere, and we have here now intersection element remaining. So we can continue now. I'm going to back to shade view, and I'm going to push this torus, and you can see we have now this sort of overlapped area. The next one is we can have Boolean split if you click on mouse left button, which means we can get every geometry which we can keep the two Boolean object, and also inside we have the splitted element. So if I take it out and if I push it away, and as you can see, we have this sort of solid object. As a result, we can get with a Boolean intersection. Let's go to another option. If you hover the icon, you can see between left and right button. I'm going to use mouse right button time to select two objects to Boolean, and I keep the input, so we don't delete input. Input means these two. And you can select either this side or that side. Do you see? So you can click on which side you want to keep as operation. You can keep click until you get what you want to accept. So for me, this is interesting. I'll keep. So I press enter. Then it's because we when we actuate the command, we say don't delete input object. So we have actually all the input object, as you can see, and the final result we can get here, which is very interesting. So that's basically what Boolean object you can do, and there's many solid operation you can do, but it's not that important. I just want to, of course, if you can master it, it's very nice, but perhaps Fillet Edge could be interesting for you. So what I'll do, I'm just gonna zoom in here. We can click on here Fillet Edge, and when you click on the edge of the joining area of the solid, and you can define different radius, and when you define it and hit enter, as you can see, we can fillet the edge of the solid joint area, which is quite nice. Fillet edge, and as you can see, you have this funny geometry with the fillet edge. there is also interesting part with the fillet edge. You could chain the edges, so I can click. Sorry, I could chain the edges. So that's about fillet edge. Now I'm going to skip the majority of tools. We have wire cut, move faces. There are a lot of solid operation. I don't even know all of them. So I think many of them you can use it for fabrication, but I'm just gonna skip for now. For architects and engineers, basically we don't really need too many solid operation. As long as you use these 4 commands here, I think it's good enough to use it. Of course, fillet and chamfers, these are also could be useful. So Champa Edges is basically, instead of fillet, we can chamfer the edges, so you can get different solid operation. So what else could be important? We did today about 1, 2, 3, 4, and 5 and 6 commands. Let's say chamfer and edges is like same kind of, so I'll leave it 5. We have 5 commands. Right, when it's solid, what could be interesting is I'm going to draw a box here, and let's make another cylinder next to it. And this time I'm going to copy this. You can hold your Alt key and then use your gumball, and you can move and you can copy this element. What I'll do, I'll explode this. So one here we have Polysurface Extrusion, and here we have surface. So I'm gonna swap the layer to layer 1, which is red color, and there's a command called clipping plane. Basically we can draw the current construction plane. Based on current construction plane, we can draw one clipping plane, and then you can move to see sort of cut out of plan view. In this case, of course, you can rotate it to 90 degree, and as long as you move it, you can see the clipped sort of section kind of view based on this clipping plane. And this edge line of the clipping plane is based on the color which you select, so you can always change the color. And when you go to rendering view, Control Alt and R, it still shows this cutting edges. What is interesting is when it's solid, as you can see, clipping plane recognize this as a solid object, so you see inside is completely filled. But another cylinder, I exploded it, so which means we have 3 different surfaces. So that means it shows only the cut edges, and we can see the inside. It's not completely filled. So this is big difference between surface and solid. When I join them, as you can see now, just 2 surfaces joined. Still we have extra surface. If I join them completely, then it becomes solid object without any naked edges. So we can see here the sort of filled solid cut result. So I can push it away. I can, it's really handy. So you can cut. Maybe I'll cut it the other way around. So you see, you can really look the clipping plane of use the clipping plane to see what's going on in your geometry. It's really funny. And if you don't want to see it, you can hide it, but hide doesn't delete the clipping plane. So I'm just gonna show. Even if I turn off the layer, still it's remaining. We're just hiding it, basically, the layer. So to disable, you have to delete it. So if it's solid, we can see the field region when you cut with a clipping plane, which is really good. What else could be important? I'm sorry that I didn't really organize the sort of tutorial today, but basically that's very simple things about Rhino. You don't have many things to do actually, but when it's solid, that means we can also type volume, and it shows volume of this current cylinder. So let me scale it down a bit, and if I type volume, then you can see that there is a volume. Of course, if I type area, it shows whole sum area of each surface. So volume and area is quite handy when you have a solid object. So when I explode it, that means these are each single surface. Even when I join two surfaces, and then if you type what, you can see they are polysurface. But when I type now volume, it wouldn't show the volume because it's not solid object. So we cannot cannot calculate volume out of surface or polysurface which has naked edges. This is really handy. And in Rhino 7, you can hold your shift and control key and then when you click on face, you can basically manipulate the geometry. So this is also very nice. So let me try one more time for this surface. So you can basically, that one more time, hold your control key and shift key, and you can click on any face and you can manipulate geometry. In this case, because that was surface and this is one single polysurface, so that's why these things happen. But you can also control shift, and you can also select the edges of your geometry, and you can manipulate the geometry, or you can click on vertices. Let me see, maybe it's easier from box. I'll just draw one more box, and if I hold my shift and control key, I can select vertex of this corner, and you can move to manipulate the solid object. Again, here you can manipulate the solid object. This tool becomes handy when you use later the Rhino 7's subdivision tool, but this thema I'll cover it next time. So maybe we can be a bit more flexible with Rhino 7 to create complex geometry. Let me think. So we have done now from solid tools, we have the solid operations and these things, and I showed clipping plane, and we can also use this control shift key to manipulate the geometry. What else could be important for architects and engineers? Let me think. Okay, I think I know. Also, there is also important tool you can use. It's called solid point on, and you can see we can select the vertex or vertices, and we can just simply manipulate. Yeah, you can manipulate the points that you select, and also with this gumball you can click in the, like, not the arrow, you don't have to drag, you can also click and you can give the distance, for example 1 meter, and it goes 1 meter. So this solid point on command is also very useful. For instance, solid point on, then if I want to move this sort of face, I can select 4 points from here. I can give -4 meter and hit enter. Then basically this whole, because of the 4 points, the whole surface is moved. So let me undo. And let me think what else is important in solid operation. Yeah, maybe it's also, I'm thinking maybe for the solid tool, that's it. for architects and engineers. Of course, you can learn more and you can go more advanced tools, but you know, that's pretty much good enough to make a architectural model or structural components. What I'm gonna show you, maybe I'm going to talk about a little bit about C-plane. In Rhino, as you can see, if you press your F7 key in your keyboard, you can disable or enable or disable the grid, your construction plane. It's always show this initial construction plane is 0, 0, 0 of Rhino. So if I put point and when I put coordinates of 0, 0, 0 and hit enter, then it shows here that's the origin of our Rhino file. But what if I want to change the construction plane so that I can more flexibly draw? For example, let's say I want to draw clipping plane again, and at the moment clipping plane is draw based on current construction plane, so it's X and Y plane. That's why we have here like that. Of course you can rotate it later, but what if I want to draw already based on some of the objects plane? So let me go here. We have here set C plane to object, which means I can select the object. You can see, you see your construction plane is already changed, and if I type now clipping plane, I'm drawing based on this object which I select. So when I click, you can see here we can display this clipping plane. Really nice, I like it. And I'm just gonna delete. Let's try one more time, and I select one of the side face surface of cylinder, and now we have this construction plane is a little bit slanted. And now if I do clipping plane, and you can see based on this current construction plane, we can use this clipping plane. Not only for that, if I draw now box, we basically draw box based on current construction plane. So you can see it's a little bit slanted because of the construction plane is slanted. And you can also go back to your original construction plane here by clicking on set C plane world top. It means the plane goes back to initial position. So if I draw box now, let me double click on change to default layer. You can see we draw box based on XY plane. You can also select the face. So next one, for instance, you can set C plane to surface. It means we can choose one of the surface. So I'm gonna select this surface, and you can define X and Y. You know, you see the orientation of X and Y. So we have now different construction plane, and if I draw now box, you see I can draw like that, which is really good. And of course here there's many options. You can choose like world back, or you know, you can set to here, you can set to bottom, front. You see, you can set again different. As soon as I click on it, you can see this construction plane location is changed, and we can just always go back to C plane world top. I think that's kind of enough because we, you know, when you work on it, for example, I want to put the dimension. By the way, dimension could be really important tool for architects and engineers. So I'm just gonna select another layer too, and let's say I want to put the dimension right now between here the width or depth of the object. So I just put dim, and then I can define first and second, and I can draw here on right now because our construction plane is world X and Y. But what if I want to put it here in vertical way? Then I could use here again set C plane to object. I can click here, and now if I place dim to put the dimension first and second, and as you can see I can draw my dimension here, and I can go back to original initial place. So this is really handy. Or what if I want to put some of the object on surface? So let me draw a couple of more boxes here, and I'm just gonna copy, hold your Alt key, and then I'm just copy some of them. So now if you go to transform, for instance, here transform is very interesting because you can actually let me find it. Box. So these three boxes, you can actually orient to the surface, which I found it's very interesting too. So you can click on orient object to the surface, for instance, and I select object which orient it, and then you can define base point and second reference point. So, and then we can select the surface. When I hit OK, you see we can actually orient where to put, and this box is one of the box now orient to this surface. Let me try one more time. So I'm going to click on orient on surface. I select object, hit enter, and let me define reference point this time here and there, and I'm going to select here as a surface. Then as you can see, we can choose now this reference point on this surface, which is really nice. Probably we can also scale these guys down. Scale, make it to 0.3 times smaller. These three objects we can also I think we can put them all in surface. So now these three objects I can define, I want to use here on this side as a reference plane, and let's select surface where we can put I'm going to select surface here, and as you can see we can along the surface we can orient our object based on that. So this is also really handy. I think for the solid operation it's really important, and you know, you can have a lot of fun. You can push it down, up a little bit, and down here a bit. And what you can do now, back to your solid tools, and we can use Boolean difference. For instance, I want to keep this solid, and I want to subtract with these boxes. So you have here this Boolean operation, and in this here on this area we can actually union them. So I'm gonna use Boolean Union 1 and 2. So they are now unioned solid object, and perhaps we can use this fillet edge. So when I click here, it doesn't let me fillet because I just joined them edges. So let me cancel, undo, Control Z. I'm gonna push this a little bit further, and I'm gonna put it up a bit so I can join them. So let's use Boolean Union 1 to union it. So we have here now this as one solid where it's not just edges. So as you can see here, we can fillet the geometry. So probably I'll give a bigger radius 1. Let's see if it works. So as you can see, it's beautiful. It works perfectly with fillet edges. So I think that's it for today. I think it was a little bit mucking around myself to explain which tool is useful, but I think we've learned about graphic settings with different graphics view in Rhino, so you can work more efficiently. And we also had a look all these Boolean operations, and we did also construction plane, how you can manipulate construction plane. And also importantly, we use clipping plane so that we can see sort of cut geometry, preview of cut geometry, which is not too bad because you can always change your background. Display property, and from display properties we can use this. Sorry, we can go to here in display mode. Rhino 7 looks shaded. Yes, we use shaded mode. Basically here we have all different mode that we used shortcut, and I'm just going to change to background to solid color to white. So Rgb Slide. That's it. I'm just gonna see like slider. It's all different new things in Rhino 7. So I'm just gonna use let's say not the slider, not the wheel. Let's use custom colorist, and I'm going to use white. So we have white background, and in this case now we can print out in PDF if you need it. Control P to PDF it. And you can choose the paper size and the orientation, and I'm going to use actual window. So I'm just draw my paper size, and let's use raster output so we can show actual cut of clipping plane with current color. Or I can also change to, let's go to rendered view, and I print. Then you can see it's beautiful result you can get as a PDF. So Rhino is really, I think it's really one of the best tool for structural engineer and architect to work with complex geometry. So thank you very much. It was a little bit disorganized this time, but I think you got pretty much what you need for working with Rhino as an architect and engineer. If you like the video, please thumbs up. And if you subscribe me, it support me a lot to continue to make some more extra videos in the future. So thank you very much. Next time I'm going to show a little bit more Rhino 7's new tool, subdivision, which is very interesting tool that you can create even crazier geometry, and it's kind of, you can convert to mesh or nerve geometry between. So stay tuned. Yeah, thank you very much. Bye bye.